Right, so last lesson we were starting to look at estimating square roots. And I thought it would be useful to put our perfect squares, these are called perfect squares, thank you, on the screen. So we can just check that one squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. So you really should try and remember those best as you can, okay? Probably up to 14. And we're going to just start off with estimating to the nearest integer. I actually think we only have to estimate to the nearest integer at the moment, so we're not going to go into decimal values, although we will talk about it, okay? So root 82, so what do? We look at our 82, root 82, and then we compare that with the two numbers either side of 82. Okay, so we certainly should write down that root 82 is somewhere between 9 and 10. Is everyone okay with that? Right, is it closer to 9 or is it closer to 10? It's closer to 9. So our value, our answer is approximately 9. That's the sign for approximately, isn't it? Wiggly equals. Everyone okay with that? Yeah? Any questions? Try the next three, please. Question 2, 3, 4, very quickly. Can you make sure you put in your inequality to start with and then your answer? No, just the whole number for now. Nearest integer. Answer to question 2. Is it closer to 10 or is it closer to 11? Yeah, approximately 11. Closer to 11 than it is 10. Because 116 is only 5 away from 121, but 16 away from 100. So it's definitely closer to 11 than it is 10. Is that clear? Okay, so 39 is obviously somewhere between 6 and 7. Is it closer to 6? Yes, it's closer to 6. And the last one, we're looking here at root 45, which is somewhere between 6 and 7. And it is indeed closer to 7. Okay, easy peasy. Yes, sir. Well, I've written approximately 9. If you say approximately 9.0, that indicates that we're doing to one decimal place, which we're not at the moment. So the answer is no to your question. Yeah. Can you see me? We're not at break. Yeah, we're at break. Can you see me at break? Okay. Yeah? Any other questions? Can you close the door behind you, please? Any questions on that? That's easy, I hope. Everyone agree? If not, speak now. Okay, we can go on to the next topic then. Okay? And the next topic is surds. Surds. Okay, so can you write today's date, 14th of September, and can you please write down the title surds? So what do we mean by the word surds? What is it the antonym of? Freddie, what's it the antonym of? Absurd, right. So it used to be the case, maybe 1,000 years ago, that mathematicians thought it was rather absurd that when they were trying to work out what the square root of something was, it was rather absurd that there could be something like the square root of 90. Okay, square root of 81, yeah. That's 9. Okay, that's not absurd. But the fact that there was these strange things that you couldn't quite square root seemed to be absurd at the time. And that's why when surds came along, they said, well, they're not absurd, they're the opposite of absurd, they are surds. Okay, so surds is the opposite of absurds. So let's just write that down. Surds is the antonym of absurd. Okay, and let's now define a surd. The definition of surd is as follows. Okay, it's a number that's in this form. So root a is a surd if, does anyone know what the definition of a surd is?
Isn't it like a square root over a square root?
No. I know what you're thinking about. That's coming later. Theo? Well, certainly, surds are exact. That's one thing. A surd is exact. But how can we determine whether or not root a is a surd? For example, is root 9 a surd? No. Okay.
So it can be cancelled down.
Yeah, it can be cancelled down. What determines whether it can be cancelled down, Freddie?
Isn't it if it has to have a square number in it?
Perfect, yes. Very good, yeah. If a cannot be factorized, into something containing a perfect square. Okay, so if you can factorize a, let's say for example 20, we'll do an example in a minute. Let me just let you write that down first. Root a is a surd if a, we'll just make that clear, that a is not just part of the sentence, just to make sure that you understand that we're talking about that a. If a cannot be factorized into something containing a perfect square. So let's do some examples. Let's do root 20. Right, let's factorize 20. Well, how can you factorize 20? 10 and 2. Are either of those perfect squares?
Yes.
10 and 2. 2 isn't a perfect square. 10, no. But how else can you factorize 20? 4 and 5. Right. Right, 4 and 5. This is a perfect square. Okay? So 4 is a perfect square because it's a square number. 2 squared. Perfect square. 2 squared. Okay? In other words, it is a square number. So root 20 is not a surd. Okay? Everyone clear with that? How about root 17? Root 17.
Is that a surd?
It
can't be factorized into a perfect square.
Yeah, it cannot be factorized into a perfect square. In fact, 17 is a prime and therefore can't be factorized in other than 1 and 17. And 17 obviously can't be further factorized. So this is a surd. Is a surd since 17 cannot be factorized. Cannot be factorized. With a square factor. Okay. How about square root of 30? Root 30. Let's try. So how can we factorize 30? 15 and 2. Anything else? 5 and 6. 5 and 6 are both 3 and 10. Neither of those are square numbers. Anything else? So 30 is 3 times 10, which is 3 times 2 times 5. How else can we do it? It's also 6 times 5. And 6 times 5 is 2 times 3 times 5. Anything else? No? Yeah, but that's not a 3.3. No? 3 and a third, you mean? 3.3 recurring, which is different to 3.3. No, it can't be. It cannot be factorized. So root 30 is a surd. Yep, and if there's no square factors, this isn't a square number, this isn't a square number, nor is this, nor are any of these, and therefore it is a surd. All right?
So you have to know the square numbers.
You have to know your square numbers. Okay. Hence, that's why we went and wrote them on the screen. Is that?
Scroll down the page a bit.
Oh, this way. Any questions? All right. Okay. So we also need to know how to turn non-surds into surds. Okay. So writing the square root of a as a surd. Okay, so if something is not a surd, we need to turn it into a surd. So let's do an example of that. So let's start off with our root 20. And what we're trying to do is to get the highest possible square number as factors. Okay, so I'm going to write this up here. So get as large as possible square factor. That's what we're trying to do when we do this. And what's the largest square factor out of 20? 4, yeah. So this 4 gives us a smiley face down here. That 4 is a square number. So what we can do is we can... 1 second, Freddie, can I... You can't see what? There? Is that enough? So we can now split this up into 2 square roots, root 4, root 5. Okay, so the square root of 2 things multiplied together, you can split them up into 2 separate square roots. Okay? Is that all right? Everyone okay with that? And we can then write root 4, which is 2. So this is 2 lots of root 5. Is root 5 a surd?
Yes.
Yes. And therefore this is now a surd, or at least a multiple of a surd. Okay? This is now a surd. Sorry? So root 5 is a surd, so 2 times a surd is also a surd.
How do you get the root 4 on root 5?
We want to split the 4 and the 5 out into 2 separate square roots. Remember, if you square root the product of 2 things, that's the product of the square roots. So we could say here that note we are using the fact that the square root of 2 things together is the product of the square roots separately. Okay? Okay, everyone clear on what I've written in that green box there? Sorry. What does it say before that bit? Writing root A as a surd.
Can you just point to the bit of the actual surd?
This is absurd. 2 root 5. Okay, and
Words absurd in brackets.
okay, so we get that 20. We factorise 20, and one of the factors needs to be a square number. As big a square number as we can get, which is a 4. And then we separate it out into 2 square roots. Because this is a square number, it simplifies. All right, into 2. And we get 2 root 5. Right, let's do some more examples from the book. Could you please turn to page 11? Page 11. Actually, page 12. Page 12. So page 12. And exercise 1.2, I'll do a couple of these with you and then I'll ask you to do some. It says simplify. In other words, if you see some sort of square root and it says simplify, it is basically equivalent of asking you, write the following as a surd. All right? Is that clear? Page 12, exercise 1.2. It says simplify a root 12. So let's factor 12. 4 times 3, yes, so this is root 4 times 3. Then split them up. And root 4 is, so we end up with 2 root 3. Is root 3 a surd? Yeah, we definitely cannot factorise 3, therefore this is the surd. Okay? 2 root 3 is a surd. Is that clear, everybody? It's quite straightforward. Some of the numbers get a little bit more difficult.
You can get different answers.
No, is the answer. You should end up with the same answer.
Keep simplifying.
Yeah, keep simplifying until it is a genuine surd.
Why is it just 2? Why isn't it 2 squared?
Because root 4 is 2. Square root of 4 is 2. Okay, the square root of 4 is 2. Guys, I don't want those silly noises in class, please. Shall I do a couple more? Yes, if it's got a perfect a factor that is a perfect square, it's not a surd. Then it is a surd. Yeah. Right. Okay. Second one. Root 44. Root 44. How do we write 44? 4 11s. Okay. Separate them out. Root 4, root 11. Everyone agrees that root 11 is a surd. And root 4 is 2, so this is 2 lots of root 11. Is that all right, everyone? Okay, carry on doing question 1, please. So you want to find nice big square numbers. So make sure you make square numbers.
There's your calculator, guys, for this quiz. Neither of those are square numbers. I think another way of factorising 75 does contain square numbers.
But if you've done that and you know what you're doing, you can carry on to question 2.
Just question 1 at the moment.
We'll do it for another couple of minutes and we'll go through some answers and check people are okay. So if you guys, if you feel okay, just go on and do question 2. If you finish question 1, go on and do question 2, please. If you feel as though you can. All of question 1, please. Just for a couple more minutes and I'll go through and check some answers. Right, let's just check some answers, please. Okay, so we did A and B. C is root 45, which is root 9 root 5, and root 9 is 3, so it's 3 root 5. D, root 50 is, remember, we're thinking as bigger numbers as we can. So rather than thinking about 50, it factorizes into 2 and something, try and think biggest possible numbers. Run down from your largest square numbers backwards that you can think of. The largest square number from 50 is 7. That's 49 and 1. But that doesn't factorize into 50, so that's no good. And then 6, and then 5, etc. So root 50 is root 25 times 2, and root 25 is 5, so it's 5 root 2. E is root 25 times 3, which is 5 root 3. F, 2 root 6. G is 3 root 7. H, 200 is 100 times 2, so it's root 100 root 2. Root 100 is 10, so 10 root 2. And then I, root 160 is 16 tens. Root 16 is 4, so 4 root 10. Did anyone not manage to get all of those right? Okay, great. Can we go on to doing question 2? Now I'm going to do a couple of these for you to start you off. Okay, question 2. It says simplify as far as possible. Okay, simplify as far as possible, root 5, root 3. What can we do here? Well, we can do the opposite way round of this rule up here. So notice this rule in red here. We can go backwards if we want to, because they're equal. Okay, we can go in either direction. So if we've got 2 square roots multiplied together, we can take what's inside each square root and multiply them together under a single square root. Do you agree? So, indeed, so this is root 15. And is 15 a surd, root 15 a surd? It certainly is, okay, because you cannot factorize 15 into any square factors. Okay, so that's that one. And that's 2a. And 2b, let's have a go at that one. Root 7 times root 4, yeah, is root 28. Does that factorize any more?
Yes.
Yeah.
Is it 2 root 7?
Yeah, it is actually. 2 root 7 is a better way. To think about this root 4, rather than multiplying, we think of root 4 as 2 root 7. Thank you. Okay? So think straight away, the first thing you need to think about is are any of these squares, perfect squares? Yeah. Okay, right. Root 5, root 11.
Root 55.
Root 55. Okay, which sounds like some sort of long car journey in the States, doesn't it? It's a famous journey, isn't it, Route 55?
No, Route 66.
Oh yeah, Route 66. Yeah, that's right. Yeah, Route 66. Route 55. There is no other way of factorizing that, so that's the answer. Let's try question F. So we got root 3, root 4, root 2, with multiplication signs in between. Yeah?
2 square root 6.
Indeed, yeah. This can simplify straight away into 2, and then the root 3 and the root 2 go together to make 3 2s are 6, 2 root 6. Thank you. Okay, so finish off those. Before you do, let's have a quick look at question 3. 3a. Root 28 divided by root 2. Suggestions, please? Somebody else? Ryan. How do we do this? Root 28 over root 2? Simplify root 28 into... Right, to simplify things, what would be nice would be to cancel out this. So this is root 14, root 2. Root 28 is root 14, root 2. Do you agree? And we've still got our root 2 there, and then our root 2's cancel, leaving root 14. And then we think, is that a third? 14. How can we factorize 14? 2 and 7, that's it. And neither of those are square factors, so root 14 is a third. Okay? So you see what we did there? So the clue is to look at this denominator. Can I simplify it there? Okay, one more, and then I'll ask you to continue. Let's have a look at 3d. This is root 60 over root 30. What do you suggest we do for that one?
Square root 30, square root 2.
Yes, root 30, root 2.
Square root 2.
Yeah, we'll cancel the root 30s, and we're left with root 2. Good. Okay with that? Everyone clear? Great. Okay, so could you continue to have a go at all of the questions from 2 and 3 that we haven't done already, please? If you've done that, just please carry on through the questions. Yeah.
So can't you just ignore the square roots and just do the numbers?
No, not at all. No. There is... or there is another way you can do it. Yes, you're right. Okay, let's just show that. Let's go back to A again. Root 28 over root 2. You can put that under a singles root. Indeed, yes, you can do that. That's perfectly acceptable. And then 28 over 2 is 14. So yes, you can. Either way is fine.
Does that work with everyone?
Sorry?
Does that work with everyone?
It will work as long as you... So here, what we're doing is we're using this rule. We're using that rule. Okay, thank you guys.